Hey guys, welcome to my YouTube channel. And topic of today's discussion is understanding big data. So the agenda for today's discussion is to take a look at the transition that we are having from data to big data. Then we are going to understand the importance of big data, and lastly we are going to have an overview of tools and technologies that can be used to design the big data services or big data products. Now the first point is, when we say a word data, the word data is something that is not at all new. We are hearing the word data from many years. Like if you take a look, maybe 20 to 25 years back, people used to manage their daily routine. Like let's take an example of a grocery shop where that particular shopkeeper used to manage all his data, all the whatever transaction he did in that particular day, or whatever business that he did in that day, he used to note it down on simple paper or a notebook or a register. That's how people used to store the data. You take some somewhat higher example, or somewhat more official example of a bank. So how banks used to store the data? Bank used to store the data on registers itself. They do have those specifically designed register where they used to store the transaction, opening balance, closing balance, or whatever their technical terminologies is. But the ultimate place to store the data was a paper. So storage medium, we are talking about storage medium, and storage medium is was the paper. Now, as the evolution of the technology happened, we have computers in our place. So we started with floppy disks, then CDs came, then DVDs came, then pen drives, and nowadays we have reached, I would say, up till external hard disks. Now, if you again see this particular transition from floppy disk to external hard disk, if you see the cost to store the data is really reduced. Let's take example of a CD. So when CDs were launched, they were the cost of a CD was like 100 or 150 rupees. So let's say at that time, to store 700 MB of data, we need to pay 100 rupees, let's say. But nowadays, if you take a example of a pen drive, if some online sale is going on a e-commerce site, you are getting 16 GB of pen drive within 100 rupees. So if you see this particular gap, I would say that will clearly describe the sentence that storage mediums are getting cheaper day by day. So since the cost of storage is reduced, the people's appetite to store the data is increased. So these two things are inversely proportional. Storage mediums are available with low cost. That's why people want to store more and more amount of data. So this is causing this particular transition from data to big data. Big data as in enormous amount of data, or volume is more. So this is first parameter. Storage mediums are getting cheaper day by day. What is the next reason? Next reason is internet, evolution of internet. Since the evolution of internet, people have a huge platform, I would say, to generate the data because of internet. You take any example, like nowadays if you go towards the any of the smallest village, people have mobiles in their hand with internet system activated onto it. You will see very less number of people nowadays that don't use internet. So this is the effect of internet on our human lives. And ultimately what internet is causing, obviously there are many factors that are being caused by internet, but ultimately data is getting generated. The simple technical term, the what internet is causing, it is increase in data. One another reason for this particular transition is social media platforms. Facebook, Twitter, YouTube, all these are the platforms that are again a source of, you know, generating more and more amount of data. So ultimately, why we have, these are the basic, these are the important reasons, I would say, that why we have this particular transition from data to big data. So first one is low cost storage mediums are available nowadays. Second one is evolution of internet, and the third one is social media platform or active use of social media platform. So this is one part of big data, that since all these mechanisms are available, since all these platforms are available, data is getting generated. But so what, even though the data is getting generated, how it is affecting people's lives, or is it affecting people's lives? So the answer of this thing is yes. So unless and until some businesses or some organizations are getting some advantage of the data that is getting generated, people won't store that. So businesses are not just storing the data because the storage mediums are available or low cost storage mediums are available. Since they are getting some kind of advantage due to storage of that particular data, they want to store it, or not only store it, they want to analyze that particular data, right? So there are two sides of the coin. One, I want to store the data, but why I want to store the data? Because I'm getting more and more business out of it. So in upcoming slides, we are going to see how the businesses are getting benefited out of data storage, how the customers or a human being are getting benefited out of again this data or big data, I would say. So here we are going to introduce one more terminology called as data point. It's a pretty much technical word, but the meaning of data point is very simple. Data point is a source from which data gets generated. Now there are enormous data points that we can say are the sources from which data is getting generated. You can take plenty of examples. Email services like Gmail, Yahoo, Rediffmail, we have a number of email services. Social media platforms. So social media platforms like we have Facebook, we have Twitter, LinkedIn, YouTube, Instagram, all these are the social media platforms using which data is getting generated. Third one is e-commerce websites, online shopping, I would say. So they do have number of products in various categories, and also number of users that are been registering on the e-commerce website for shopping purpose. Again, that is one source from which data is getting generated. There are many that we can list, like you have weather sensors, you have parking sensors. What these guys do, or what these devices do, they gather data, sorry, they uh, you know uh, generate data. So basically all these are the data points. Now since I was mentioning in the last slide that people want to store more and more amount of data because they are getting benefited out of it. Now using one example, I'm going to demonstrate you how people are getting advantage of this particular data, as well as the another side, businesses, how organizations or companies are getting more business by storing and analyzing all these data that is being generated by these platforms. Now let's take example of three data points. One is my email id, the another one is a social media platform like Facebook, and one more platform is e-commerce website like Flipkart. Let's take these three. Let's consider my email ID as a@gmail.com. So since all of you know that email ID is an entity that cannot be duplicated at any cost. Email IDs are always unique. When I say a@gmail.com, this email ID is unique and that cannot be generated by some other person. So this is my unique ID, right? And 99.9% of time I use this particular same similar ID to log into a social media platform and similar email ID to log into e-commerce website. So I'm going to use a at the rate gmail.com to log into social media platform like Facebook, and a at the rate gmail.com is going to be my user ID for, let's say, Flipkart. So let's take a scenario where I have taken, let's say, a new flat. So what I will do, since I'm living in the uh, social media generation, I would say, since I am happy, I will post it onto my Facebook wall saying that I have purchased a new flat, feeling happy. This is what a normal activity I will do. Now, for posting this particular post on my wall, I have used a at the rate gmail.com. I will use a at the rate gmail.com to log into my e-commerce website also. Now, these data points, my email service, my Facebook account, my social media account, and my e-commerce account, since their main asset to do a business is data, they do share their data amongst them. Whatever amount of whatever kind of accounts they do have, whatever kind of pages I have liked, whatever post I did, they do share this particular data amongst them. So as soon as I do this particular post onto my Facebook wall saying that I have purchased a new flat, feeling happy, this particular post is being shared to my e-commerce website saying that, hey, e-commerce website, a at the rate gmail.com has a new post with, text as I have purchased a new flat, feeling happy. Now, as soon as this post reaches to a e-commerce vendor, they do have some sentimental analytical algorithms running at the back end which will analyze my post. So based on their algorithmic strategies, they will analyze this particular post and they will come up with a recommendation saying that since this guy has purchased a new flat, the next thing which he may need is a minimum bare furniture into his house, right? This is a very common scenario. If someone has taken a new flat, then he will definitely go and search for a minimum bare furniture. So as soon as this data is getting shared in between these two platforms, I am going to get a recommendation onto my email service or onto my phone number as a text message saying that, hey, this is a 20% off on furniture. And we keep thinking, saying that, how come my e-commerce vendor knows that I am looking for a furniture? We think this is somewhat a magical thing. And since I am getting it onto the 20% off discount, I who don't want that particular thing, I will obviously go and purchase the furniture, because anyways I am getting it in my the quality which I desire, and obviously with the less cost. So this is how this business happens, and which is beneficial to the companies as well, like e-commerce vendors, and me as a customer as well, because I am getting 20% of discount. I am happy, and my e-commerce vendor is also happy since he got a customer or he got the more business. Now if you see the root cause of this particular uh, purchase, let's say I have purchased that from my e-commerce vendor. So if you see, the root cause of this particular purchase is nothing but the post which I did. That was one line which has given business to e-commerce vendor. So now you can think in reverse way. If they have not stored my data, or they have not processed my data with their sentiment analysis algorithms, will they be able to generate these recommendations for me? So the answer is no. That's why, since business are companies are getting more business because of storing and analyzing the data, they want to store that. So we were discussing about why somebody will store the data. Unless and until they are going to get some business out of that particular data, they will not store it. And here is an example or a use case we saw where they are going to get some business, or the probability of getting business is increased because of storing and processing the data generated online. We call it as big data. Big data is nothing but like enormous amount of data. Okay, so this is the uh, concept of data point. So up till now we have seen 2 points basically. One is, we are, since because of all these reasons we have enormous amount of data, and because of storing and analyzing of this particular big data, companies are getting more and more business, customers are getting more and more options to purchase the things, or to uh, review it, or there are n number of use cases that you can think of. So since the companies and customers are both are getting benefited out of this, it becomes very important for a customer as well as for a company or for a business to store that particular data generated by internet or generated by your social media platform. We call it as social media analytics. So if they don't do this, then somewhere they are lagging in terms of their business. So again, coming towards the importance of big data, behavioral analysis, like, so the kind of recommendations that you get is something which is not at all new. Just the medium is different. Here you are getting online recommendations, right, based on your behavioral analysis. Now let's take an example of again the same thing, a social media platform and my e-commerce vendor. So my e-commerce vendor always maintains the history of my purchase. Whatever I have purchased from that particular website is always been maintained by my social media vendor, and based on my likes and dislikes they will generate more and more recommendations for me. If my social media if my e-commerce vendor analyzes that this particular guy is mostly interested in autobiographical purchase of the category, then they will recommend me more in that particular same category. This kind of behavioral analysis is being done by this sentimental analysis algorithm. Ultimately these algorithms need more and more data. So more and more data, more and more accurate recommendations you will get. Predictive analysis. Predictive analysis is nothing but the you know the recommendations, or on Facebook, let's say we usually see people you may know, or on any of the e-commerce website, book you may like or product you may like. These kind of recommendations are nothing but predictions that you may like this. So all these predictions are being generated by the data which is available onto their sites and my likes and dislikes. So they get to know about my likes and dislikes based on my previous purchases or my history, I would say. Now we are coming towards some of the design factors of big data. If somebody wants to design the big data platform, then what are the factors they should consider, right? So there are 4 V's of big data. First one is volume, velocity, variety, and veracity. So what are the differences? Again, because of all these reasons of storage mediums, then internet, and then social media platform, the volume of data that is getting generated is huge. Again, velocity is nothing but what is the traffic per second of data. That is again huge. Now you just see the number of users of Facebook, Instagram. What is the frequency that Facebook data is getting generated? You just cannot count that, not even in seconds. There are billions and trillions of users of Facebook. Facebook is only one social media platform. There are number of social media platforms that are popular like Instagram, LinkedIn, YouTube. So you just cannot count this particular velocity, that how much data or what is that frequency in which new data is coming onto this particular social media platform. Then variety. Now since all these mediums, social media platforms can have various varieties of data, not only text. They do have text, audios, videos, then images as well. So there is a variety of data. And the fourth one is veracity. Now since all this is a virtual world, we should always analyze that how much we should trust on this particular data, and that can be counted in the last parameter called as veracity. And it's nothing but how much you should trust. Is there any validations that we can have to you know come to a conclusion that whether this particular post is true or neutral, how we should treat that particular post? Because it can, since it has n number of advantage, it may have some disadvantage also. So all these things comes under veracity. So volume is size of data that is getting generated. Velocity, how much data is getting, or what is the frequency of that particular data. You may count it with some mathematical formula, per second frequency, per minute frequency, per day, or whatever, per hour or whatever. Variety, as I told, we have text, we have images, we have audio, we have videos. This is the variety of data. And veracity is trustworthiness of that particular data. Should I trust this particular Facebook post or not? Is there any way to handle this particular question? This particular thing comes under veracity. Now, if someone wants to design a big data platform or big data service, then they should have in their service or in their particular design architecture, they should address all these four V's. So first V is volume. They should have a capable infrastructure which is capable of handling volume of data. So, and it should be scalable again. Then velocity, the frequency of data that is going to hit is also, your infrastructure should be able to handle that particular velocity. Variety, your system should be able to store all varieties of data, that let it be a image, let it be a audio, let it be a text, and let it be a video. Your system should be able to store that particular data. Not only store that particular data, but your system should be able to process that particular data as well, because there is no use of just storing the data. So it's like two sides of the coin. If you want to process the data, then you have to store it, obviously. And if you just store it and don't make any use of it, then that's a useless storage, right? So these are the two things that you need to take care, or these are the four things that you need to take care if you are trying to design a big data platform or big data service. Now, we whatever up till now, whatever things we have discussed was mostly onto the business parameters of it, that by getting the social media data, how it is benefit, by having the recommendation into it, how it is beneficial to customers, how it is beneficial to businesses. All these kind of discussions are being happened up till now. But to have all these systems in place, you need that much capable technology as well, that much capable infrastructure to store all these kind of huge amount of data. You need smarter algorithms that are capable of processing these kind of data. So we are going to take a very high level overview on what kind of technologies that we can use to store this particular data and to process this particular data. So basically, when we say that I want to design a big data system or big data service, there are two things to it, or there are two sides to this particular coin. One, how you are going to store that particular data. First of all, you need to think of this parameter, that what is the size of my data that I'm going to get. So I should have that much capable infrastructure to store that particular data. And the another side of the coin is, let's say I have stored that particular data. Do I have any, the equal smarter algorithm that will process my data in, very less amount of time? Because since the data amount is large, your algorithms should be fast enough to process that particular data very quickly. Okay, so we need to think of these two things. Let's take a look on storage mechanisms. So if I need to store this particular data, where you just cannot mention the volume of data, you cannot have fixed size volume of your data, that may increase day by day. So you need some distributed storage systems like GFS, HDFS are some of the examples of a distributed storage system. GFS is it is not at all open source. It is the patent, we would say, of Google. GFS stands for Google File System, that Google uses internally to store the data. HDFS is nothing but Hadoop distributed file system, that is currently getting used by almost, all the companies who want to store and process big data. So Hadoop distributed file system is one of the hugely used example of distributed storage systems. Then again, there is one more hot word, we can say, of cloud computing, onto which you can host some of your services. So there are a number of cloud providers we have, like Amazon EC2, then Microsoft Azure, and IBM Software as well. So using this any of the one of the cloud computing platform, you can store and run your algorithms onto these data platforms. These are the very high level storage systems that we are seeing, and in my upcoming videos we are going to see the more and more details on each of these particular platforms, like HDFS, how do I store my data, or what are the internals of HDFS. But as of now, I am just going to give you a high level overview of all these storage mediums. So this is about storage. I need some distributed storage system which is scalable of storing all this kind of big data. Now the second point to this is fast processing engines. So there is no use of just storing the data. I would need smarter algorithms to store to process my data. So couple of examples of some processing engines as well. So MapReduce is one of the open source data processing engine that we have. Hive is again a query engine that can be built on your Hadoop distributed file system. Another processing engine is Spark, that is been given by, again, it's an open source technology given by Apache. And some of the NoSQL engines as well are available, like MongoDB, Cassandra, and Neo4j. All these are the independent technologies that are pretty much capable of storing and processing the big data. We are, as I mentioned, we are going to see all these things into details in my upcoming technology. This is very high level overview of these things. So that's it. Thank you for watching my video, and do subscribe to my channel.